this right here is the formula you're going to be using when you're trying to find out the volume of revolution of trapped areas. In the previous video, we learned about how we can find the volume of revolution between a curve and one of the axes. So basically, if I have my axis over here, this is the y and the x, and let's say you have some curve over here, and there's some area beneath this curve, say like that, and you want to find the volume of revolution when you rotate this thing about the y-axis, about the x-axis, then you can basically do that by using the formula we learned in the previous video. However, in this video, we're trying to find out the area that is trapped between two curves. So let's say something like that, and then something like that, and hold on. I'm going to try and draw that a little more clearer. So something like, oops, I'm trying to draw a line, something like that. And let's say there's this area that is trapped between these two curves. So you can see that this trapped area is not between the curve and either of the axes, but instead it's trapped between this curve, this line right here, and this curve right over here. So how, let's say you're trying to rotate this thing about the x-axis, and you're trying to find the volume of rotation. How do you do that? Well, first of all, you can remember that there's this formula that you're going to be using for trapped area. So whenever you see a trapped area, you first, of course, need to identify that. Once you've identified it, now you can go ahead and apply that formula. So it's basically this thing where you got this and that, and then you got brackets over here, brackets over there, and then you got this thing right over here. Okay, so we've set up the formula for the volume of revolution of trapped areas. Now all you got to do is, first of all, you know that you're trying to rotate this area about the x-axis. So since it's about the x-axis, everything needs to be in terms of x. So you go ahead and you put a dx over here. Right, then you need to find your bounds or your limits, so the upper limit and the lower limit. So you can clearly see that right there, that intersection point right there and that intersection point there are basically the bounds, and you can kind of extend those and get the x coordinates for them. So let's say this right here is 3, let's say that right there is 5. So your lower bound is going to be 3, and then your upper bound is going to be 5. And then in here, you're basically supposed to put the equation for the upper curve, and over here you're supposed to put the equation for the lower curve. So let's say the equation for this curve is basically y equals something, 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 and then the line is basically y equals something, something, something. So how do you go about this? So you just chuck this equation in here, and then you just chuck the other equation in here, and then you just integrate all of this. You just solve all of this out. And remember, once you've created this thing, don't forget your integral properties, don't forget your algebraic properties. Okay, remember all of that stuff. You're either going to have to use this kind of integration, or you're going to have to use this kind of integration. Okay, these are the two integrations that we've learned, so keep these two in mind. And remember, this sneaky little 2 over here, this is probably going to play a role. They're probably going to give you some tricky kind of an expression inside of these things, and it'll basically have to do something with this too. And then once you do that, you basically need to get these integrals in these forms so that you can integrate them. So remember all of that stuff, right? And now let's say you have this same sort of a curve. You have the same sort of curve, and then you have that line over there. And you're trying to, there's that area between these curves, and this curve and a line, and you're trying to this time rotate it about the y-axis. Okay, so how do you go about this now? Well, you just write your formula. You just write your formula as you did like before. And then since this time you're trying to find it about the y, what you're going to do is you're just going to put a y over here, and then you're going to put the bounds over here, but this time the bounds are going to be different because that intersection point, this time it's going to have the y-axis as its bound. So some y value over there and some y value over there. Be careful, not the x bounds, but instead the y bounds, because this time we're trying to rotate it about the y-axis. So let's assume that the lower bound is 2, and let's say the upper bound is 6, so you put those in there, and then now you have to write these equations for the curves and the line. And since we're trying to rotate this area about the y-axis, you need to get the equations in terms of y. And how do you do that? Well, you're basically going to make x the subject. So when you make x the subject for the curve, you're going to get something in terms of y. And when you do the same for the line, you're going to get something in terms of y. So just pick those things up and you chuck them in here. Just pick all of those things up and you chuck them in here. And then you just solve this out like you usually solve out your integrals, and you're going to get your volume of revolution. Now remember, you do need to be careful when it comes to identifying the upper curve and the lower curve, or upper curve and the lower line. So if you have something that sort of looks like, let's say like this, then you need to let's say that's the area, and you're trying to rotate this, let's say 360 degrees about the x-axis. So you have to identify that, okay, for this shaded area, that right there is the upper curve, and it's not a curve, it's a line. So the upper line right there, that's on top, and then that right there is the lower curve that's at the bottom of that shaded area. So you got to be a little careful when it comes to identifying the upper and the lower curves, because otherwise you're going to put the wrong things inside the brackets and you're not going to get the answers.